Welcome, Julia Brodskey. Can you share a little bit about your background with our listeners today?
Hello, and thank you so much for inviting me. I'm originally from Russia, where as a child, I really loved sci-fi stories. So this is probably why I went into space physics when I graduated from my school. So, and afterwards, I moved to the United States. I worked a little bit at Rice University as a researcher. And later I joined NASA as a contractor at Johnson Space Center, where I was teaching astronauts for several years, which was an amazing time. I really enjoyed it. And from there, I worked as a physics and math teacher at private schools because I was very curious about American education after I started family. And then I worked at NASA a little bit more and worked as a private school teacher. And at some point I decided, after seeing how engaged the kids are when I talk to them about space, about astrobiology, I decided to start something on my own online. And it was right pre-COVID. So
yeah, it's been an odd time with education in general since then. Tell us why astrobiology and kids. Most people would think that that is way too high level for them. So how do you bring it down to their level?
So I actually think that astrobiology is a great introduction into all types of sciences because astrobiology is such an interdisciplinary field. When you talk with kids about life on Earth, you talk to them about how everything that we are made of was initially made in stars, right? So all the chemicals we are made of are made in stars. When I start talking with kids now about astrobiology at our first class, I ask them, what do you need to start a campfire? And they would tell me, well, you need wood. And how do you get wood? Well, you need soil. You need water. So where does soil and water come from? And then they also say, we need sunlight. Where does the sunlight come from? Can we actually have all of that without having our planet and without having our star? Very quickly, it turns out that in order to have something, you need everything else in this universe. They see that everything is interconnected. So I think astrobiology is an amazing way to show that interconnectedness of all types of sciences to the kids, how astronomy is connected to chemistry, to geology, to biology, to paleontology, because we're studying the life on early Earth. So unwrapping, the big picture of sciences to the kids.
Right. I want to go back to what you said. You said a number of really interesting things. Let's go back to when your early influences, were they more science fiction writers? Were there maybe some shows that you got, maybe even Doctor Who or Star Trek or Star Wars? What were your influences? Isaac Asimov, Ray Bradbury? Where did you find your inspiration as a child?
So there were not that many shows in Russia back then, even though there were some. So it was mostly Bradbury and Asimov and Stanislaw Lem. He's a very famous and a wonderful sci-fi writer from Poland. Sheckley and others. Yes, absolutely.
So I was listening to your other podcasts that you had posted, and you had said those same things. And, when we look at sci-fi today, right? When I'm trying to, in fact, I just introduced a unit to some high school students I was working with. It's still so relevant in the writing, even though it's, considered older to them. They can still see how what was envisioned by those early authors has come to pass, almost kind of in a dystopian sense. So when you think back to, your time as you were coming here to study education in America, what are some differences that you noticed, not only as a student, but even as a teacher, between even here and, say, Russia?
Oh, well, first of all, we're talking different times. I think the education in Russia nowadays is different from the education I got when I was a child. But I think Russia was more focused on like the rigor of the science, but so kids were given a pretty good, deep foundation. I was surprised actually when I just came to the United States that you get physics only in the 9th or 10th grade, because in Russia you start in 5th or 6th grade and it goes through all the years. So they start with giving the kids some introductory physical education where the kids just develop the intuition and then you build on that base. It's very difficult here in the United States for the kids to start using formulas without actually having enough background on just playing with the things. When I was teaching at a private school, I learned that my students, like in 5th or 6th grade, never played with little mirrors before. It was such an amazing thing. When I was growing as a child, we would play with little sunspots all the time. So we kind of got to understand, the laws of reflection, for example, just by playing with them all the time. My students, it was the very first time for them when they were allowed to just play with those things and given an opportunity.
Right. I'm a biochemist by schooling, right? I did not become an educator until much later, but I find the intersection between biology and chemistry, that's the second most, I think, interesting sort of discipline you can have is sort of the chemistry of life. I always tell my kids that physics is the queen on the chessboard. Everything is physics. And then the next closest queen of the science, if you will, is chemistry. But almost everything is physics or chemistry or some application of those principles. With your astrobiology, with our science fiction here that I grew up on, the writers would make life forms that simply weren't based on the molecules that we have, right? So you would have life forms. Of course, everything is anthropomorphized so that you can have human people play these characters, but there were some life forms that weren't based on carbon, or carbohydrates and lipids and proteins. And that was always interesting to think that the diversity of life out there. My question to you is, does the Drake equation make it into your classes with your kids?
Absolutely, yes. So we actually, I taught Drake equation to different groups of kids. And the most recent time I did it was at the mathematical circle I ran for American Indian kids. So just a second. So it is the American Association of Indigenous Mathematical Circles, and they invited me to talk to the kids about space and mathematics. So we were talking with the kids about how do we estimate different things, and I asked them, how would you estimate the amount of other civilizations in our galaxy? So together with the kids, we first of all had to think about what are our assumptions. First of all, do we assume that the life only lives on a Earth-type planets orbiting sun-like stars? So this is what goes into the Drake equation. If we have other assumptions, then we would have to modify the equation. So then we would start unwrapping all of this. So let's say we only think about life on Earth-like planets. So we have to estimate the amount of sun-like stars in the galaxy first. And then we have to figure out how many of those have planets. And then how many of those planets may have liquid water to support life. And then how many of those planets actually have some sort of life. And then on those planets, which fraction of planets actually support some intelligent life. And one of the most mysterious questions, even if you get, to estimate those planets, for how long a civilization on those planets would be interested to communicate with us.
Right.
So, or able to communicate with us. So all of these questions are, you can definitely discuss all of these components, all of these factors with the kids.
Right. I think with young kids, my experience is it's difficult for them to wrap their heads around the large scales of time and the large scales of distance, because on top of all those great points you made, where is, at this moment, where is that particular star out there that has some planets around it? Where is it in its life cycle, right? Is it early in its life cycle? Is it later? Because, I think our Earth indicates you need a long period of time for, life to evolve to a certain place. I think that's very fascinating. Just this week, Elon Musk was talking at the National Academies of Science, and I had one of my Zoom classes. We watched him for about 40 minutes, and then we talked about what he spoke about. But he seems to be driven about trying to prevent our collapse as a species because we're only on one planet. And so that led to great conversation with kids about extinction level events. And I just thought that was interesting as well, because although those planets you mentioned, how many planets might have been affected by those stray asteroids and comets and things like that, either spreading life or destroying life.
And since you were mentioning some of the coursework and how you bring that material to students, let's talk a little bit about your company and also, your website. I was checking it out earlier today. Tell us a little bit about the Art of Inquiry and how some of our listeners can check you out.
Sure. So the Art of Inquiry is an online interactive program for kids 10 to 14 years old. And we offer a 3-year-long curriculum. So the first year is focused specifically on space travel and astrobiology. And these are the topics that are very familiar to me because, of course, I worked as an astronaut instructor for many years. I worked as a system engineer for many years. I got my education as astrophysicist. And I also work a lot with astrobiologists right now because I'm also a STEM education lead at Blue Marble Space Institute of Science, which is focused on science communication and astrobiology. So for the second year, I think when we're talking about the education of a child in the 21st century, I think we need to show them their place in the universe and also teach them about themselves. So while in the first year we talk about the universe mostly, in the second year, we talk about mind in the universe. So we talk with the kids about cognitive sciences, we talk about artificial intelligence, and we talk about communication being an essential part of any complex system or intelligent system. So we also talk a lot about complexity as a concept and emergence of complexity. This is a point that is rarely discussed at school, but I think nowadays we're building such a complicated, such an interconnected world. We really need to talk to the kids more about it, about the behavior of complex systems and also the emergence of different and new complex systems, and how to analyze them and at least how to observe them, how to notice them around us. So the topics we discussed in the second year is the minds of animals. And we talk about human minds, we talk about brain, we talk about artificial intelligence in relation to human brain, and also all the existential risks and opportunities that come with the development of AI mind. And we also touch a little bit about such concepts as crafting a message to extraterrestrials, something that SETI and METI are doing. And it actually takes us back to Earth and teaches us about ourselves as human species. When we're designing a message to extraterrestrials, what do we want to say? what is the most important to us as humans? We need to craft a message describing ourselves as humans, but also something that will stay unchanged over those thousands and maybe millions of years that the message will go through space. So what is essential about us as human beings? So this is a very deep question that we as civilization need to discuss.
No, that is a deep question. I mean, I'm thinking about that. I'm not even sure I could answer that. And so I imagine, like, you know, some of the kids that we work with, they'll build space settlements and things like that. And they have to take into account some questions like ethics and, you know, the idea of governing laws and how would we have these settlements. And so oftentimes getting them to understand this is not an ethnocentric future. It's not just America going and planting a flag or some other country just planting a flag like we've done to our earth. It's going to be a combined effort. And how do we make those decisions? So that's pretty fascinating. How does, when you're doing your class, oh, go ahead.
I'm sorry, you didn't tell us about year 3. You did
Yes.
year 1 and year 2.
Absolutely, yes.
Sorry.
So
Yes,
in the year 3, I tell the kids, you know what? Now you know quite a lot. Now it's your time to build the future. I was telling you about the upcoming future, but it's your time to actually do it. So in the year 3, we discuss the future studies. We discuss futurism and different approaches to building future. And also the kids are doing a lot of things themselves. For example, right now they are hosting webinars with leading scientists. They are running their own podcasts. So they're building a website. So lots of hands-on projects. They're also participating in different contests, and they plan to participate, I hope it will happen, at EPSICon 22. It is an international astrobiology conference. And we hope there will be a virtual poster session for the kids to actually come and submit their thoughts on philosophy of science, on ethics, on astrobiology, and so on.
Yeah, you know, when you can get students to participate in those kinds of conferences, we've found that that's been overwhelmingly one of the best ways for students to actually, let me adjust our connection here just in case it looks like, I think we're okay. For a student to actually be able to not only learn something, but to be able to share that with others really reinforces that they actually have learned something. So we've attended several conferences where students have done posters as well as, and we just went to the International Astronautical Congress where students actually spoke about some of their research. So it's great to see someone else is doing that with kids.
Right. I had the good pleasure of meeting Peter Diamandis several years ago. He started SED, Students for the Exploration and Development of Space, when he was at MIT, and he's one of the founders of Zero G. And I would call him a futurist because he talks about having using our technology to solve problems in a way. I think he wrote a book called Abundance, where we don't have to go hungry. We can feed ourselves. We can take better care of the planet. He's got a really positive outlook about how the future could be for us as a species when we leverage the technology to solve these problems we have. I'm curious, could you share, I didn't catch the name of that conference. Can you tell me what's the name of the conference that you're hoping to have your kids in, and when will it occur?
Sure, it's called EPSICon, short for Astrobiology Science Conference. And it will take place this May in Atlanta, Georgia.
No, that's not
very cool.
And another thing that I wanted to mention is that the kids come to my classes from all over the globe and from all social strata. Since astrobiology is something that is new to everyone starts at the same level. So even the kids who didn't have a chance to learn science before, I have kids who come to me from low-income families, from immigrant families, and so on. They all know that astrobiology is such a new emerging science. It's open to questions that adults don't really know much. So there is not that much authority in astrobiology. So these kids, it's such a pleasure to see them, to take part in discussions, to imagine, to brainstorm with everyone. And by the end of the first year, even those kids who come with zero science background, they catch up because they get so motivated. They go and read on their own, they watch YouTube on their own. These kids exchange links and books. So it is such an amazingly motivating way of inviting kids into scientific discussions.
I have not met you before today, but there are a lot of similarities in what our programs are. So it's really great to meet someone who has a similar outlook. We never want a child cannot help where they grow up or how much or how little they might have in terms of resources. But young kids are very curious, and we should leverage that curiosity and, help point them to some information and let them drink it in. Yeah. So
as we kind of come to a close here, I want to make sure that I'm going to list your website, if that's okay with you, in our podcast notes as well. But before we leave today, and before my last question, which is always like words of wisdom that you have, how would a student, when they're looking to sign up for your classes, are they weekly classes? I know that they are over 3 years, but how often do your students meet? And then I'll get to that final question. I just wanted to get that one in.
Yes, the students meet once a week. So.
Okay, so they sign up they kind of start year one. So then they're kind of in a cohort with other students who then they progress up the level.
Right,
okay, fantastic.
Right,
so I'm gonna put that link there. We always end with the same question. Our audience is made up of students, some parents of our students, and some teachers who are also like-minded. So if you have some listeners out there who might be thinking about going into astrophysics as a career, what advice do you have for those young listeners today?
Don't be afraid and ask questions. Questions are essential for science. All science is built on questions. And don't be afraid that you don't know the answers. Just ask the questions. And the questions give you the direction. The questions give you a motivation. So start with questions.
Right. That's a great piece of advice. Would you agree with me that you can almost estimate a person's intelligence not by what they know, but the kind of questions they ask?
Absolutely. Actually, when I teach undergraduate students how to assess themselves as teachers, I tell them, just look at how many questions your students asked today. If they asked a lot of good questions, you're a good teacher. You don't need any grades.
Right, that's fantastic.
Great.
Well, we look forward to talking with you more. I believe that, like Kevin said earlier, there are some ways that we definitely overlap and ways that we might be able to work together. So thank you so much for giving up your time with us today. And, we look forward to talking with you again.
Thank you.
It was a pleasure meeting with you and talking with you today. Thank you so much. And I'm definitely looking forward to talking more with you. Thank you.
Thank you.